Welcome to the fourth lesson of the DevOps course. In this lesson we will learn about the fourth stage of DevOps, build. The build stage in the DevOps lifecycle is where the actual software is built, compiled, and packaged into a release. It involves the use of various tools and technologies such as build automation tools, version control systems, continuous integration servers, and containerization technology. The build stage refers to the process of converting developed source code into an executable software application that can be deployed and run on a target environment. The key components of the build stage typically include build tools, which are software programs that automate the process of building an application from source code. Popular build tools include Maven, Gradle, Ant, and Make. Compilation is the process of converting source code into machine-readable instructions. During this process, the code is checked for syntax errors and translated into a format that can be executed by the target environment. Testing is an essential component of the build stage, as it ensures that the application is free of bugs and meets the required quality standards. Unit testing, integration testing, and regression testing are some of the testing techniques used during the build stage. Testing tools and frameworks like Junit, Selenium, Sonar are some of the many options available based on the technology stack used for development. Packaging involves bundling the application and its dependencies into a deployable format, such as a jar file or a Docker image. Version control systems such as JIT and SVN are used to manage changes to the source code and ensure that the correct versions of the code are used during the build process. CI/CD tools such as Jenkins, GitLab CI/CD, and Circle CI are used to automate the build process, including testing, packaging, and deployment to ensure that changes are quickly and safely deployed to the target environment. The build stage is critical in the DevOps lifecycle as it lays the foundation for the rest of the stages. If the software is not built correctly, it can cause issues down the line, leading to delays and increased costs. Hence, some challenges that organizations may face during the build stage include maintaining consistency across different environments, managing dependencies, and dealing with legacy systems. To overcome these challenges, organizations can use tools such as Docker, Kubernetes, or Ansible, which can help with containerization, orchestration, and automation. Build tools are software programs that automate the process of building, testing, and deploying software applications. Build tools is the key component of the build stage in the DevOps lifecycle. We may have to use different types of build tools based on the scale of development, technology landscape, and nature of collaboration. There are several types of build tools, including build automation tools automate the process of compiling source code into executable code. Examples include Apache Maven, Gradle, and Ant. Continuous integration tools automate the process of building and testing code on a continuous basis. Examples include Jenkins, Travis CI, and Circle CI. Dependency management tools automate the process of managing dependencies for software applications. Examples include Apache Ivy, Gradle, and Maven. Release management tools automate the process of deploying software applications to production environments. Examples include Ansible, Puppet, and Chef. Containerization tools automate the process of packaging software applications into containers for deployment. Examples include Docker, Kubernetes, and OpenShift. Code analysis tools automate the process of analyzing code for quality, security, and performance issues. Examples include Sonark, CheckStyle, and PMD. The right set of build tools can help organizations achieve faster development cycles, better quality. The build stage of the DevOps lifecycle involves the creation of the software artifacts that are necessary for the subsequent stages of the process. Here are some best practices for the build stage of the DevOps lifecycle. Automate the build process. Automating the build process reduces the possibility of errors and improves the speed of delivery. Use tools such as Jenkins, Bamboo, or Travis CI to automate your builds. Create a reproducible build environment. Create a consistent and reproducible build environment by defining the dependencies, configurations, and environment variables necessary for the build process. This reduces the possibility of errors and ensures consistent build outputs. Use build catching. Use build catching to speed up the build process. This involves catching intermediate build artifacts such as compiled code and dependencies to reduce the time required for subsequent builds. Use a continuous integration tool. Use a continuous integration tool like Jenkins, Circle CI, or TeamKitty to automate the build process and trigger builds automatically when changes are made to the codebase. Monitor the build process. Monitor the build process to ensure that it is functioning as intended. Use tools such as Grafana or Prometheus to monitor build metrics such as build duration, success rate, and failure rate. By following these best practices, you can improve the quality of your code reduce errors and improve the speed of delivery. You have successfully completed Lesson 4 of the DevOps course. In the next lesson we will deep dive into the fourth stage of the DevOps lifecycle.